Hello everybody, Zero Fossil Fuel. First of all, I want to thank everybody for all their fine suggestions with regards to the 12 volt solenoid valves that I was looking for. Had a number of very creative suggestions. I did end up finding some for about $1.25 a piece, so I bought 5 just because. Now, I may or may not end up using them, but I wanted to thank everyone for all of their suggestions. This is the Toyota. This is the vehicle that the VSPB cell is installed in right now. Just want to take you for a quick tour around because I'm going to be making a few changes in a short while, but I wanted to show you the way it's set up right now and why I'm having the problems that I'm having. Now, down below the bumper on the lower left hand side, you can see the actual cell. Okay, we're going to go in a little closer now, and maybe I have to go to macro. Alright, there's the cell. Let me back up a little bit. Unfortunately, yeah, I guess you can see down in there pretty well. It's held on there with just a very large tie wrap against this rail, which runs in front of the radiator. And then down below, it's strapped to the aluminum cross member, or the aluminum bumper actually, behind the plastic. The pipe runs through this opening here, comes up and it loops around and it goes into the top of my bubbler. Now it's disconnected because I have to disconnect it every single time I actually use this thing. Coming out of the bubbler, it loops down and I have it loosely tie wrapped to the radiator hose, which does two things. It keeps it out of the way of the radiator fan, and it also helps to evaporate any fluid that might build up inside the tube, because the tube is warm, being kept at the raised temperature of the radiator hose. Now I'm going to lift the intake manifold cover, which I've already unscrewed, and take it away here. And this right here is the PCV, positive crankcase ventilation valve return to the intake airstream. You can see the air box is right there. Comes into the plenum. This is the electrically controlled, servo-controlled throttle mechanism. This entire vehicle is fly-by-wire. There is no throttle linkage. So the butterfly valve for the accelerator is inside here, inside this aluminum housing, and the injector just sits right in front of it. Pop it out here for you. And you can see how the tube just sits in the airstream as the HHO is injected. Now this has been completely warmed up, and I'm not sure what the cell temperature is right now, but I wanted to take an actual measurement of the gas production with the vehicle running at 13.8 volts. Okay, the engine's running. The first thing I'm going to show you is the amount of current going into the cell. Take a few measurements here. I'm seeing roughly 28 amps across the 4-man shunt, because I'm seeing 28 millivolts across the shunt, so that translates to 28 amps going into the cell. At 28 amps, it is at 12.7 volts, 12.69 volts. And my cell temperature right now is 108 degrees Fahrenheit. So let's zoom out a little bit. And with my stopwatch in hand, I'm going to connect it to the output of the bubbler. 1, 2, 3, go. 18 seconds. So a little bit more than a liter and a half, not quite 2 liters per minute, maybe 1.75 liters per minute is my output at 12.7 volts, 27 amps. I can't vouch for the ultimate accuracy of the 4-man shunt, but I can vouch for the accuracy of this meter, which is 0.09% accurate. One of the things I'd like you to take note of and pay attention to is the height differential between the bubbler as it sits right now and the cell. The bubbler sits quite a bit above the cell. Now, I'm going to be using one of the methods that was suggested to me rather than the solenoid valve, in that I'm going to be sharing the electrolyte fluid reservoir. And to do that, I'm going to take this bubbler and I'm going to physically mount it to the side of the electrolyzer tank so that the level that I want the bubbler to be at will be at the same level on the sight tube for the electrolyzer cell. And to do that, you have to physically mount them together. And to physically mount them together, you need quite a bit of room to do that. And fortunately, as you can see, I've got quite a bit of room to do that. So the bubbler will actually sit right here and probably rise to about halfway above the radiator. And they will share the same fluid reservoir by means of a connection tube at the very bottom of both of these containers. The benefit of that is that any bubble or any foam that happens to be pushed out into the bubbler is immediately reclaimed as part of the same electrolyte reservoir, and it's just recycled. And it still achieves the desired result of filtering out any airborne potassium hydroxide. I also want to mention that in situations where space is limited, and you do have to separate the bubbler from the cell, as I have it right now, in a situation like this, it is extremely desirable to use the 12-volt operated solenoid device instead of sharing the electrolyte reservoir, because you physically have the limitation. You can't put the bubbler next to the cell, so to locate it someplace else, you can't guarantee that it's going to be at the level that you need it to be at physically in relation to the cell, so that the fluid levels remain where you want them. With the solenoid valve, all you need to do is put a T-fitting probably right at the inlet to the bubbler, okay, so that once the cell shuts down, the valve opens and allows fresh air to return down the feed tube instead of sucking the water out of the bubbler. Over here you can see I've again installed the poor-man shunt, and the poor-man shunt has the ground wire going directly to the chassis, and we have 8 gauge wire going to the negative terminal of the cell. I have my positive terminal coming off a 6 gauge into a fuse, into a 30 amp relay, and then off to the cell. The 30 amp relay coil is connected to ground on one side, and the other side is connected to a control wire that runs inside the passenger compartment through that grommet at the back by the brake booster, and it is energized through a switch on the dash panel that receives its power from the fuse block from a ignition power source, so that when the key is turned off, this relay right here cannot be energized, and it cannot send voltage to the cell, allowing the cell to run when the vehicle is off. You always want the cell to turn off when the vehicle is off.